Good afternoon, everyone. Welcome and thank you for joining this session on AI governance and regulatory compliance. Today, we are presenting a strategic blueprint for establishing a robust artificial intelligence management system, or AIMS, within our organization. This presentation is prepared for our board of directors, legal counsel, CTO, and compliance officer. Our primary objective is to establish an auditable, risk-based framework that guides the responsible development and deployment of AI technologies. We are navigating a rapidly evolving landscape, and our goal is to be proactive, not reactive. We will be focusing on the key frameworks that are now defining the global standard for AI governance: the EU AI Act, Regulation EU 2024/1689, the Certifiable International Standard ISO/IEC 42001-2023, and the NIST AI Risk Management Framework, RMF 1.0. This blueprint will demonstrate how these frameworks complement each other to create a comprehensive governance structure. The integration of non-deterministic artificial intelligence systems that can produce different outputs from the same input, represents a paradigm shift. It moves us from traditional IT security, which focuses on protecting data and infrastructure, to comprehensive algorithmic governance, which focuses on the behavior and impact of the algorithms themselves. The EU AI Act is the centerpiece of this new regulatory environment. It imposes a rigid, risk-based approach, establishing strict legal obligations that are directly proportional to the potential impact an AI system could have on fundamental rights and safety. This is not a recommendation. It is the law. The stakes are incredibly high. Noncompliance exposes the organization to severe financial penalties, up to 40 million euros or 7% of our global annual turnover, not to mention the significant reputational damage that could result from a scandal involving unethical or unsafe AI. To operationalize these legal requirements, we look to ISO/IEC 42001-2023. This is the first certifiable international standard for AI management systems. It provides a structured framework based on the Plan, Do, Check, Act cycle, allowing us to integrate these legal obligations into our business processes. By proactively integrating these frameworks, we are not just checking a box for compliance. We are ensuring verifiable accountability, transparent data governance, and a robust capacity to mitigate the inherent risks of algorithms. This is how we build trust and a competitive advantage.
At the heart of the EU AI Act is its risk-based classification system. This matrix is the first step for any organization in determining its obligations. First, we have unacceptable risk. These are AI systems that are considered a clear threat to people's safety, livelihoods, and rights. Examples include systems for subliminal manipulation, social scoring by governments, and real-time biometric surveillance in public spaces. These are completely prohibited within the EU and are excluded from the scope of an AIMS. Next is the category that demands the most attention: high risk. This includes AI systems used in areas like critical infrastructure, biometrics, employment, like CV screening software, and healthcare. These systems require full compliance with the Act. This means implementing rigorous data governance, ensuring human oversight, maintaining automated logging, and going through a conformity assessment process. For ISO 42001, this requires the stringent application of specific Annex A controls, particularly those related to the AI lifecycle, data quality, and customer relationships. Limited risk AI systems have specific transparency obligations. If a user is interacting with a chatbot or a deepfake, they must be informed that it's AI-generated content. This is addressed via controls related to information for interested parties. Finally, minimal risk systems, like spam filters or AI in video games, have no specific obligations, though voluntary codes of conduct are encouraged. A crucial category is GPAI and systemic risk. This covers powerful foundation models and large language models. Their sheer scale and capability create new risks, requiring technical documentation, copyright compliance, incident reporting, and adversarial testing to manage their potential for systemic harm. Accountability under the EU Act is not limited to the creator of an AI system. It is distributed across the entire AI value chain. This slide maps the legal obligations of different actors. A critical point to remember is that a substantial modification to an AI system, as defined in Article 25, can legally transform a user, or deployer, into a provider, thereby taking on a whole new set of responsibilities. Let's start with the provider.
This is the entity that develops an AI system and places it on the market under its own name. Their obligations include implementing a quality management system, conducting conformity assessments, providing technical documentation, and ensuring automated logging. In ISO terms, this aligns with controls on the lifecycle, data quality, and customer relationships. The deployer is the user who uses an AI system in a professional capacity. While not the developer, they have active duties. They must ensure human oversight, monitor the system's operation, retain logs, and respect the provider's instructions. This is addressed by ISO controls on the use of AI systems and internal organization. Importers place AI systems from outside the EU onto the EU market. They must verify that the provider has done their job and ensure that technical documentation is available, which maps to supplier relationship controls. Lastly, the distributor makes an AI system available in the EU market. They must verify CE marking and that the product has been stored and transported correctly. This matrix shows that every actor has a role to play in ensuring responsible AI, and our governance framework must account for our position in this value chain. To govern AI effectively, we must understand the underlying technologies and their specific risks. This slide begins that analysis. Supervised and unsupervised machine learning relies on training data to identify patterns. The regulatory risk profile here is significant. These systems are susceptible to non-deterministic behavior and a critical threat known as data poisoning, where an attacker corrupts the training dataset. This makes high reliance on data governance controls absolutely essential. Moving to deep learning and neural networks, these use complex, multi-layered architectures for advanced pattern recognition. The primary regulatory implication here is the black box problem. The decision-making process is often opaque and difficult to explain, which severely limits explainability. This directly challenges the transparency requirements of the EU AI Act and the ISO 42001 controls on understandability. To mitigate this, we require robust verification and validation procedures and comprehensive explainability documentation. We must be able to justify why an AI made a particular decision, especially when it impacts people's lives. Now we turn to the technologies that are currently at the forefront of public and regulatory concern: NLP, LLMs, and generative AI. Large language models are foundation models trained on vast datasets. Their risk profile is distinct, with high risks of algorithmic hallucinations, data leakage, and copyright infringement. When we talk about generative AI, which can create text, audio, or images, it poses systemic risks regarding disinformation and deepfakes. Regulatory-wise, these are classified under GPAI, with potential systemic risk. The requirements are strict. Users must know they are interacting with an AI, and the models must undergo adversarial testing to identify vulnerabilities. For ISO 42001, this type of AI demands rigorous impact assessments, continuous monitoring for model drift, where its performance degrades over time, and systemic risk treatment. We need to be able to foresee and manage these new large-scale risks. Finally, let's look at 3 other key technologies. Computer vision enables systems to understand digital images and videos. When applied to areas like real-time biometric identification, it poses an extreme risk to fundamental rights and is often classified as unacceptable or high risk under the EU AI Act. On the other end of the spectrum are expert systems and rule-based AI. These operate on predefined heuristics rather than purely data-driven training. This offers significant advantages in transparency and auditability, making it much easier to comply with human oversight requirements compared to deep learning. Reinforcement learning involves an agent learning through trial and error to achieve a goal in an environment. It presents specific risks of unpredictable behavior, especially when applied to autonomous physical systems or digital environments. It requires distinct testing methodologies to ensure safety and predictability. This slide provides a comparative summary of the key AI technologies, their use cases, and their regulatory implications. For example, deep learning used in medical diagnostics is classified as high risk and presents a low intrinsic explainability, the black box. This necessitates extenuating documentation and a human-in-the-loop approach. LLMs and generative AI, used in chatbots for document analysis or content generation, are classified as GPAI. They require high transparency to label AI-generated content and manage the risk of hallucinations, requiring impact assessments and systemic risk monitoring. Computer vision, used in surveillance, is often unacceptable or high risk, requiring strict data provenance to prove data sources are legitimate and to mitigate inherent demographic biases. Finally, expert systems, which are rule-based and often used in diagnostics, can be minimal to high risk. Their high transparency makes them easier to validate and audit, with straightforward logging requirements. This analysis helps us prioritize our efforts by focusing on the technologies that carry the highest risk for our specific use cases.
The AIMS is not built in isolation. It utilizes the harmonized structure, a common high-level structure for all ISO management system standards. This ensures seamless integration with our existing frameworks, like ISO EIC 27001 for information security and the GDPR for data privacy. The diagram on this page illustrates how the AIMS fits within our overall organizational structure. It's not a separate system, but an extension of our existing governance. The AI Supervisory Committee provides strategic oversight, guiding the development and use of AI across the company. This committee relies on the AIMS, which defines the life cycle, processes, and controls for our AI systems, all while ensuring compliance with the EU AI Act and other regulations. This integration is key to efficiency, ensuring that our compliance efforts are unified and not creating silos.
This slide is perhaps one of the most practically important in our presentation. It shows a direct mapping of specific EU AI Act requirements to their corresponding controls in ISO IEC 42001. For instance, Article 9 of the Act, which mandates a risk management system, is directly addressed by Clause 6.1.2 and 8.2 of the ISO standard, which covers AI risk assessment. This allows us to use the standard's methodology to meet the Act's legal requirements. Article 10, on data and data governance, maps to Annex 8.7, which provides controls on data quality, provenance, and bias mitigation. Article 12, concerning record-keeping and logging, is covered by Annex 8.6.2.8 on event logs, ensuring immutable logging for traceability. Article 13, on transparency and information provision, maps to Annex 8.8, which guides the drafting of comprehensive system documentation and model cards for users. And finally, Article 14, which requires human oversight, maps to Annex 8.9, providing the framework for implementing human-in-the-loop controls and intervention protocols. By implementing ISO 42001, we are building a system that inherently satisfies the core technical requirements of the EU AI Act, which provides a legal presumption of conformity.
AI systems introduce unique cybersecurity and operational threat vectors that simply aren't covered by traditional IT security protocols. This slide visualizes the distribution of these AI-specific threat vectors, which include adversarial attacks, data poisoning, model theft, and privacy violations. To manage these risks, we apply a formal risk equation. Our residual risk equals our inherent risk times 1 minus the effectiveness of our controls. This means our residual risk is the inherent risk of the AI system, such as its non-deterministic nature, multiplied by the effectiveness of our control measures. The goal is to reduce the residual risk as much as possible. Effective implementation of the Annex A controls, like lifecycle testing, data governance, and monitoring, directly reduces the non-deterministic risks. This slide underscores that a dedicated AI-focused risk management process is not just a legal requirement, it's an operational necessity to protect our organization from these new and complex threats. Effective AI governance cannot be left to the technical or legal teams alone. It requires a multidisciplinary AI supervisory committee that bridges the legal, ethical, and technical domains. This committee, as illustrated, is the apex of our AI governance architecture. Its role is to provide executive oversight, ensure that our AI strategy aligns with our ethical values and business objectives, and to act as the final arbiter in complex risk decisions. The architecture also emphasizes human oversight, which is a key principle of the EU AI Act. It's not about replacing human judgment, but augmenting it. The human-in-the-loop controls and intervention protocols ensure that our high-risk AI systems are supervised by qualified individuals who can intervene if the system's behavior is not as expected.
This human-centric approach is critical for maintaining control and accountability. The first phase of the AIMS life cycle is inception and design. This is where we define the objectives, intended use, and critical use cases for an AI system. A crucial activity at this stage is the AI Impact Assessment, as per Annex 8.5. This is a process that helps us understand the potential impact of the AI system on individuals and society, particularly concerning fundamental rights. It forces us to consider who will be affected by this system, how might it go wrong, what are the potential harms. By conducting this assessment early, we can design the system to avoid or mitigate these risks from the start, rather than trying to fix them after the fact. This is a foundational step that informs all subsequent stages of development and deployment.
Achieving legal compliance and ISO certification is not a single event, but a structured, cross-functional process. This slide outlines the implementation flow. It starts with project initiation and scoping, where we determine what AI systems are in scope. We then conduct a thorough gap analysis against the EU AI Act and ISO 42001 to identify what we need to build or improve. The next critical step is to develop and implement the necessary policies, procedures, and controls. This is the do phase of the PDCA cycle. Then, we must audit and review these controls to ensure they are effective, the check phase. The EU AI Act also requires that certain high-risk systems undergo an external conformity assessment by a notified body. Once the system is compliant and the processes are in place, we move to the act phase, continuous operation, monitoring for model drift, and continuously improving the system. This flow ensures that we are not just compliant on day one, but remain so throughout the entire lifecycle of the AI system.
To conclude, let's look at our strategic roadmap. It's critical to remember that the EU AI Act introduces staggered enforcement. Some obligations came into force earlier, while others are phased in over time. This timeline provides a clear path for us to implement the necessary governance and controls. Early adoption of ISO IEC 42001 is a strategic move. By aligning ourselves with an internationally recognized standard, we are not just preparing for the EU AI Act. We are building a best practice governance system that gives us a legal presumption of conformity. This roadmap is designed to achieve operational readiness well before the key deadlines, turning a compliance burden into a strategic advantage. By demonstrating our commitment to responsible, trustworthy AI, we build trust with our customers, partners, and regulators, and we position ourselves as a leader in the ethical and effective use of AI.